Sources of error in numeric or floating-point computation. Quantum Mechanics by Maple is a complete course, contains 38 videos for beginners. During this course, student will be able to use Maple step by step in quantum mechanics. The first video of this series explains mathematical expressions, the second video explains mathematical functions, and the third video explains exact quantities and numeric quantities. The fourth video of Quantum Mechanics by Maple discusses the methods for converting exact quantities to numeric quantities. The fifth video of this series discusses the types of computations, including symbolic and numeric computations. The sixth video of Quantum Mechanics by Maple discusses the first type of computation, symbolic, abstract, or exact computation. The seventh video of Quantum Mechanics by Maple discusses the second type of computation, numeric, or floating-point computation. This video is the eighth video of this series and discusses sources of error in numeric, or floating-point computation. As it expressed earlier in previous videos, there are two types of computations. 1. Symbolic, or exact computation. 2. Numeric, or floating-point computation. Numeric, or floating-point computation, is the mathematical manipulation of expressions, or functions, involving numeric, or floating-point, quantities. In numeric, or floating-point computation, expressions, or functions, involving exact, or symbolic quantities, are replaced by close approximations, using numeric, or floating-point quantities. In Maple, numeric, or floating-point computation, is normally performed if you use floating-point numbers. Numbers containing a decimal point. By its nature, numeric, or floating-point computation, normally involves some errors. Controlling the effects of these errors are the subject of active research in numerical analysis. Some sources of error are: 1. Exact quantity arithmetic and errors. 2. Floating-point quantity arithmetic and round-off error. 1. Exact quantity arithmetic and errors. An exact quantity may not be exactly representable in decimal form. Here are some examples of representation error in decimal representations. Increasing the number of digits allowed in a representation reduces the magnitude of possible errors. 2. Floating-point quantity arithmetic and round-off error. Arithmetic operations of floating-point quantities can accumulate small errors. In order to illustrate and discuss round-off errors, let's consider some simple examples in Maple. Example 1. Subtraction of nearly equal floating-point quantities can result in small errors. If y equals root x squared minus x, x is a number, then find y. In this example, result must be y equals 0, but result reported by Maple, or a typical calculator, is not always 0. Let's illustrate this example by Maple for the following data. x equals 0.00011. X equals 0.00038. X equals 0.0005. X equals 0.00083. Increasing the number of digits allowed in a representation reduces the magnitude of possible round-off error. Example 2, one large and one small number. If A equals 11 and B equals 0.00000038, then find A minus B. The result reported by Maple, or a typical calculator, is A minus B equals A. It means Maple ignores this small number, and so there is a small round-off error. Let's illustrate this example by Maple. In the next video, we will discuss how to reduce the errors by increasing the number of digits in Maple.